Hi everyone, this is day 2 evaluating limits algebraically. In the last video we did everything by looking at graphs, and now we're going to do just the opposite. Just by using our pencil and paper we'll be able to arrive at the limit. So there's 5 rules that we have to be aware of. The last 3 are pretty easy to understand. The first 2 are also pretty easy to understand. It's just that it takes a little bit more explaining than the other ones. So in the first one, the constant rule, if k is a constant real number, then the limit as x approaches a of that function k is also equal to k. So in looking at that, it's not hard to memorize that, but it'd be easier if you knew what it meant. So if k is a constant, that means it's a number. So I'm just going to say it's 1, for example. So if this is like your f of x, this is your function, like f of x equals 1, for example, or y equals 1, then that's just a horizontal line going through the y-axis at 1. So now it would be easier to understand that as x approaches a number a, whatever number it approaches, let's say it's approaching 1. Well, as x approaches 1, you can see the graph is constantly staying at 1, so the limit would also be 1. If x approaches, let's say, the a value of 2, then the answer is still going to be 1 because it's 1 the whole time. So it makes sense as to why the limit as x approaches a of a constant number is that constant number, because it will always be a horizontal line. So as far as you look right or left to find the limit, it'll always be whatever this constant is, whatever the k value is, whether it be 1 or 2 or -5, whatever. So the second rule, the limit of x rule, this just says the limit of x as it approaches a of the function x. Well, this function x, let's say either you have y equals x or f of x equals x. Same thing, it's that diagonal line that goes right through quadrants 1 and 3. So as you approach an a value, whatever a value it is, let's say the a value of 1 you're approaching. Well, if you're approaching the number 1, then look at the y value, it's also 1. If I were to approach the a value of 2, as you approach 2, it's also going to be 2 because it's the line y equals x. So if x is 1, then y is 1. If x is 2, then y is 2. So it makes sense that if you are approaching a number for a function x, that the answer is whatever number you're approaching here. The next three, excuse me. Sum and difference rules. The limit as x approaches a of f of x plus or minus g of x is equal to the limit as x approaches a of f of x plus or minus the limit as x approaches a of g of x. Basically, it's just saying it doesn't matter if you write it this way or this way, it's the same thing. This almost is reminiscent to me of the distributive property. You're either writing it separately like this or together like this. It's the same thing for the product rule. If you see a limit written this way with 2 functions being multiplied, the answer is the same as if you have, if you find the limit of one of those functions first and then multiply it by the limit of the other function second. And lastly, the quotient rule. It's just that. If you find the limit as x approaches a number of f of x over g of x, it is the same as finding the limit as x approaches a for the first function divided by whatever answer you get when you do the limit as x approaches a of the second function. With the quotient rule, as you'll see, it's one of our last examples that we'll do today, you will notice that there's just one extra little step that we have to remove what's called the holes in the graph. So we'll just kind of go through a bunch of these rules over here. The first one here, the limit of 3 plus 2x as x approaches 4. And then we're doing this all algebraically over here. So all we're going to do is take this number 4 and plug it in the equation. And I'm going to do it 2 ways. I'm going to do it the way I see it here, and I'm also going to do it by expanding it with the product rule. So let's take a look here what happens. If I expand it, using the, excuse me, the sum and difference rule. I said product rule a second ago, that's incorrect. If I use the sum and difference rule, I could leave this limit like this and find the answer by subbing in, or I could break it up. So if I'm just following this right here, I have 3 plus 2x. I'm just going to break it up. I'm going to find the limit, f of x being 3 and g of x being the 2x. See how it's broken there? So now in this scenario, this goes back to my rule number 1, because see how k is a constant, 3 is a constant? So in that scenario, the limit of a constant is always equal to that same constant. So the answer to this is 3. Remember, because this is just a horizontal line going through the y-axis at 3. So no matter what x value you approach, the y value will always be 3. So if I do the next part, the limit of 2 times the limit of x, that's using the product rule because it's 2 times x, so the limit of 2 times the limit of x. So if I just do the limit of 2, again, that brings me back to my constant rule. The answer will just be 2. And for over here, the limit of x, that brings me back over here. The answer will be a, which is 4. So 3 plus 2 plus 4 is 11. Now that's kind of fancy. It takes into account all those rules up there. But even faster than that, I can just plug in the 4. So if I plug in the 4 right away over here, 3 plus 2 times 4, I also get 11. But at least the other way, you got to see those rules in action a little bit. So let me do a couple more. Second one. So if I have a function here, again, I could split it up if I want to, but I'm just going to leave it the way it is because it's faster, as you saw. The limit of 3x squared as x approaches 5, just replace the x with the 5, PEMDAS, 5 squared is 25 times 3, we've got 75 total. Next one, you can go ahead and stop your video if you'd like, guys, and try it out on your own. And if you're coming back to me right now, again, you can just see I just did my PEMDAS here, replace the x values with 2 cubed first, then times 8, or I'm sorry, 2 cubed would be 8, then times 4, and then subtract the 12 and add 1, and we're at 21. A couple more examples I want to show you. One with a radical in it, no big deal there, just something different. Again, you can hit stop, try that out on your own, and come back in a second. And if you did just that, you replaced the x with a 2, you came out to radical 9, which is 3. Now, as an example here, if this came out to radical negative 9, like let's say the answer was this, then you would say the answer is does not exist because we can't have an imaginary answer there. So just as a side note there, if the answer came out to an imaginary unit, like radical negative 9 would be 3i, for example, then you would just say the limit doesn't exist because that's not a real number. There might be a question like that in the test. I think that's what I'm thinking of right now. Okay, so I want to get to the quotient rule questions because I said there was something different about those. So right now there's the question. When you've got the quotient rule, what you want to first do, if possible, factor the numerator and the denominator. Okay, if it's not factorable, that's fine, but that's where I want to start. So if you factor the numerator, it's an easy trinomial. X minus 5, x plus 2. The denominator does not factor, so I leave it. When you have something over itself and they cancel, it creates a point of discontinuity in the graph, and you need to remove that, okay? So remove this first, and then what you're left with, if you just replace the 5, replace the x with the 5, 5 plus 2 is 7. So that's just the one little trick I think out of this whole lesson is that when you have the quotient rule, if it can be factored, you should factor it. Just because it's factorable doesn't mean that something's going to cancel, but if it does, you should remove the discontinuity point first prior to subbing in this number. So you can try that now again with this example. Again, go ahead and stop the video and try it out. So if you did that and you factor, we do again have a point of discontinuity. And if you graph this in your graphing calculator, you would see that there's a point of discontinuity. You may not visually see it with the graph, but if you looked at the table, there would be a point of discontinuity when x is 1. So keep that in mind. So I removed these, and now what I'm left with is x plus 3 over x minus 2. This is what I'm going to use to plug in this value. So when I plugged in 1 into the x plus 3, x minus 2, 1 plus 3, 1 minus 2, I got an answer of negative 4. So that's it for this lesson. If you'd like to try some homework questions, there we got, I didn't write all the numbers. Page 842, I guess you're seeing a sneak peek of them right now. Page 842, looks like I've got 1 through 29 odd you could try. So page 842, 1 through 29 odd you could try out. Next week, or at the, next week we'll have 2 more lessons and then just a short quiz. I'll make it pretty simple. So you just have like a little bit of a leg up on the competition, knowing something about limits before you go to college. So aside from that, guys, have a good day. 2 more lessons next week, a test next week, and then that will be it. If you would like to do the bonus activity, there will be a bonus activity for that last short week of school, the 8th through the 10th. But it's clearly optional. Have a good day.